All right, so good morning in Germany and good evening in Australia. It is a pleasure for me to talk to you about ESMValTool that Julie had introduced already in just very briefly. I will give you a little overview of what ESMValTool is and what it can do. But so for me, so I'm very happy to talk to you about this, but it's not something that I do. This is a community effort. And so I basically talk on behalf of everybody who has ever contributed anything to ESMValTool and made it better and more accessible and better usable. So to understand where ESMValTool comes from, I go a little bit into the CMIP background. In 1995, CMIP began under the auspices of the working group on coupled, coupled modeling, which is part of the World Climate Research Program. Its objectives is to better understand past, present, and future climate changes, and the analysis are based the CMIP analysis are based on a multimodal context. Over time, the definition of rules on how simulations are supposed to be submitted became more and more defined and refined, and standards for data about units, time variables, etc., have been updated over the course of over the generations of CMIP. The analysis based on those climate model simulations that were submitted to CMIP became more and more complex over time. So at the moment we are at the Earth system models and not climate models or general circulation models, which are just very complex things, as you might know, which brings us to CMIP-6, the latest, the most recent version of CMIP. If we are not counting CMIP-7, that is just starting now. More and more institutions and consortia have registered. There are more models registered than CMIP-5, more experiments defined, more model output expected, and higher complexity and resolution of the simulations, which is a challenge for the community to actually look at the different simulations that were submitted and make sure that we understand what's going on, that we do the science with it, that we want to look at the analysis. And so that's where basically ESMValTool comes in. ESMValTool is an Earth system, it's called ESMValTool, but it's short for Earth System Model Evaluation Tool. It's a community diagnostics and performance metrics tool for the evaluation and analysis of Earth system models. As I mentioned, it's a community effort. It's both open to users and developers. It encompasses a wide scope. It has many diagnostics and performance metrics covering different aspects of the Earth system. It's highly flexible. New diagnostics or observational data can be easily added. We support multiple open source languages. We try to go more and more in the direction of Python. It just makes it easier to maintain the code, but we also still accept for ESMValTool code in NCLR or Julia. We have a provenance that is pulled through every steps that we do that makes it easier to reproduce the results. We have a well-documented source code and the diagnostics that I had mentioned. We have an online tutorial for the easy introduction on how to use ESMValTool, and we are working on a governance structure, which basically just tells people on how ESMValTool is governed, where we want to go, how directions of development are set into place. And I put a tiny little trophy on the bottom right here, because since a few weeks, we are actually award-winning software. The Helmholtz had announced a software prize for different aspects of software, and we won the very first sustainability Helmholtz software prize. So we are very proud of that, and that's why we have that little trophy on the bottom there. ESMValTool, as I mentioned, is an open source community development. We develop on GitHub. We have over 200 developers and more than 60 international institutes participating. We are very proud that we have contributed to several chapters of the assessment report 6 of IPCC's Working Group 1. Since the release of version 2 in August 2020, we have had regular releases, and at the moment we are at release version 2.11 that was released in July 2024. On the right, you see 5 different papers that describe ESMValTool version 2 in different aspects, the technical overview, the Rigi et al. Paper on the top, but then there's like 3 papers that describe different diagnostics, and then the paper on the bottom from Manuel Schlund in 2023 is a further development that I will talk about in a little bit. So ESMValTool basically looks like this in a nutshell. We have some input data on the top in the blue box, dark blue box, that goes into the black box, which is called ESMValTool. It's not really a black box because you can really see everything that's going on. But the data goes into ESMValCore, which is solely based on Python. And then from there, it's everything, the reading, the pre-processing of data, everything, the data handling is done with ESMValCore, and you can see the light blue box on the right is different pre-processing functions that are available that will make it easier to process the data and put it on the same grid or make it available for the diagnostic that you want to do with ESMValTool. We have the pre-processed input data after everything has happened in ESMValCore, and then we go to the red box, which is the diagnostic. And then we get, we do some science with it, and then we get the outputs that could be a graphic file, a netcdf file, and we have different log files. Everything is handled with a recipe that is the purple box that on the left, and the rest, and then several, you can put define different settings with different configuration files that are in green. So that's basically it in a nutshell. We have different features, and I just wanted to highlight a few here. We have started working on automatic data downloaders. We have wildcards that are allowed in the recipe now, which means that we can directly connect to ESGF, download the data that we specify in the recipe, and then don't have to kind of manually do that before. ESMValTool will do it for you. We have, increasing number of observational and reanalysis data sets available. ESMValTool does not provide any data sets with its code, but we provide code that we call summarization scripts that basically will do the downloading and the summarization of data into easy steps, I would say. And so you have the data available very quickly yourself. So this is our way around of why we allow to provide data, although we are not really providing it. We have started using the preprocessor function, extending preprocessor functions in all directions, depending on what the community needed and what the community wanted. They are the commonly used data processing operations that avoid reinventing the wheel over and over. And then we are working on improved data handling and memory efficiency by using DAS consistently. We are close to finalizing that, which will make reading of high resolution data, for example, or many different simulations for different applications a lot easier. All right, so let's show you, I will show you a few examples of what ESMValTool can do so that you get an idea of what you could use it for. Of course, at the core of like ESMValTool is the multimodal analysis. And I just wanted to show you 2 of the figures from the IPCC AR6 Working Group 1, Chapter 3. That were done with ESMValTool, and the recipes are available in ESMValTool if you wanted to redo it for a different subset of models or a new generation of model simulations coming in. So yeah, we are looking at anomalies of near surface air temperature. That's a typical plot that you probably have seen plenty of times. And then also pattern correlations showing the progress of different CMIP phases for different variables that you can't read, but this is not the point of that figure, of me showing it right here. But there's plenty of other diagnostics available. For example, we have cloud diagnostics that you can see on the top here. We have we're looking at different scenarios and kind of like temperature and how temperature evolves over time depending on different scenarios that we're looking at. But then we're also having have different realms covered. So far it was only atmospheric diagnostics, but we also have land diagnostics, or in the case of the example here on the lower right, this is the AMOC evolution that has been added as a diagnostic into ESMValTool and can be used. So, but the multimodal analysis is only one thing that we can look at with ESMValTool. What we have started doing is that we intercompare different observations and reanalysis. This example that I show you here is precipitation that we looked at and intercompared with different reanalysis and observations, as I mentioned. It was part of a project, and we kind of realized halfway through the project that that would actually be a pretty cool thing to do, because ESMValTool doesn't really care if it's a model simulation or if it's observations or reanalysis. As long as the data is in the right format, you can do intercomparisons and kind of looking at things. At that specific case, we actually just looked at a specific region, the tropics, and then we can mask the sea out or the land out, and so you can look at different things at land and ocean only. So that was quite neat. But then we realized that the Spark reanalysis and the comparison project was just finished in its first phase, and we realized after we heard a presentation from one of the leaders of that activity that ESMValTool actually could be very helpful in producing or intercomparing different reanalysis data sets, because that's basically what we do. We regrid, we interpolate on the same levels, and then we intercompare. And so we are starting now participating in the APARC ARIP phase 2. And what you can see here is one of the things that we started looking at. We're looking at clouds in the different reanalysis data sets. Everything in black is are 4 observational data sets, and everything in color are different reanalysis data sets. And you can see there's quite a spread, and that's something that we want to explore a little more with ESMValTool. Okay, so one of the things that we realized is that, of course, the summarization, or making sure that the data is in the right format, is something that prevents people from using ESMValTool as a monitoring tool, for example, or something to look at simulations very quickly after they have been finished being calculated. And so what we implemented some blueprints on how to actually use ESMValTool without summarize the data first. So on the left, so this is basically a little flow diagram that shows you a little bit differently how ESMValTool works. As you can see, we have the data on the top left, and then we have the final output on the bottom right. And in between there are these gray boxes. And so normally what happens is that we have summarized data, we go into the gray boxes, we find the data, we do the CMO check, the data is CMO compliant, and that's on the in the middle on the blue circle there. And then we do some regridding, extraction, masking, whatever, and then the pre-processed data goes into the diagnostic box. With the native model, reading native model output, we basically do a summarization light on the fly, which means that we basically do a mapping of variables, units, and things like that, that we need to make sure that the data is kind of CMO compliant without actually do the summarization beforehand. And so that goes, kind of like works that the native model output goes into the data finder, then we do some very specific fixes. This is a dark gray box. Then we go into the CMO check, and from there on it's the same workflow as if you had summarized data. At the moment, it's the native model output. Making that we can read native model output is available for 5 different models. So this is basically a matter of making sure that the mapping of variables, as I mentioned, and the units is done on the fly, and that needs to be implemented in ESMValTool. But since we have 5 examples, that should be that can be relatively easy expanded to other models. That's what we think. So that the advantage is that we have the native model output that we can process directly. So no summarization to be done before. There are no special user settings, and then you have like the rich collection of ESMValTool diagnostics right available after you read the native model output. We started doing that and expanding a little in that direction to actually monitor some simulations that we are doing here with ICANN. But this is from Manuel's paper from 2023. So we call it we call those very simple diagnostic the general purpose diagnostics, where you just can see basically 2D variables, where we have, for example, on the upper left, air temperature from simulation from the model EMAC, and then we intercompare it with ARA5, and then we have a bias plot, and you can see like what the hell is going on. On the right is a simulation, the line plots, a simulation with ICANN, intercomparing near surface air temperature and precipitation with ARA5, and you can see how the simulations behave. And so that is something that is highly customizable, of course. You can look at any kind of variable that you want. Those diagnostics are very easy, easy to handle and programmed in such a way that they can handle the different variables. And that is why we started that, is because we wanted to monitor the running climate model simulations, that we have to make sure that nothing is out of the ordinary and nothing is out of bounds. And that brings me to the point that one of the latest projects that we have submitted, that we have worked on, is the benchmarking. And so we have 4 different metrics available now for benchmarking. We look at bias, RMSE, Pearson correlation coefficient, and Earth mover distance. And with the benchmarking, we compare with different observation and reanalysis data sets, and also the suite of CMIP-6 simulations. It's a paper that we submitted to GMD. You can look it up if you want to. We think it's very, very cool. Opens up a whole new possibility for like what you can do with ESMValTool. So what we did is we have a simulation that runs 10 years, and the first 5 years are using sea surface temperatures, as you can see on the left. This is the regular distribution of sea surface temperatures. I think it's the mean that you see here of the 5 years. And then on the right is something where we just have the sea surface temperatures, kind of like on a more regular scale. The mean of those different periods is basically the same, but we wanted to see what our benchmarking would do when we actually have something weird going on in a simulation, and if we can detect that. And so what you can see here is basically the new capability of ESMValTool, that you have a simulation that is shown in red, you have an observational data set that is shown in blue, in black. In this example, it's near surface air temperature anomalies, and then you have all kinds of gray lines. This is like a whole suite of CMIP-6 simulations, and then gray dashed lines that show you the multi-model percentile, 10 and 90%. And you can see, sometimes the simulation is in, sometimes it's out of bounds, but you can see very clearly in 2005 where there is a break, basically, where the sea surface temperatures change and something weird is happening. If you look at the RMSE that's on the right, you can see that basically the simulation is very closely within the blue area, the blue shaded area, which is the RMSE for the CMIP-6 model simulations. And you can see that in this specific case, you can't really distinguish between the early or the later period where something goes wrong. Everything is basically within the bounds of the CMIP-6 models, and so you can't really see here that something is off. But we can, of course, look at different things. In this case, we are looking at the annual cycle, and you can see here in the annual cycle, you look at the red and the blue. The red is the early period of the simulation that we're looking at. Blue is the period that where we fix the sea surface temperatures. And you can see that, that there is a little difference. The blue line is a little further away from the black line, but it's still perfectly in the middle of the simulations in gray from CMIP-6. And then on the right is the RMSE again, and you can see that the red has a clearly better RMSE than the blue. That would be an indicator basically for how, if you understand your model, how well this would work. But we can also look at maps, of course. And so here in this case, you're looking at a map of precipitation, RMSE of precipitation. Everything that's hatched is between between the 10th and 90th percentile. And then everything that's that's not hatched is out of bounds, basically. And you can see that the out of bounds regions are getting a little bigger, depending on how close, on the period. So on the second half of that time period that we were looking at, you can actually see that something is happening, and you might want to check your simulation. The same, of course, is possible with a different 2D view. This is at this point the bias of air temperature we're looking at. And then especially here, you can see very clearly that something might be off in the second half of your simulation. That said, this is just an example to illustrate things. If you, of course, would not look into different halves of simulations or something, if you would use that for benchmarking a simulation, you would just look at the full simulation and then see how things behave. If you do that with a simulation that is working, that is great, was well tuned and worked perfectly fine, and then you look that use whatever you're doing with the new simulations in comparison, I think that's where the strengths come in, where you can actually see things happening very easily. So the benchmarking against the different observations and reanalysis we can do with 4 different metrics so far. This is possible to extend that. It's very helpful for model developments, looking at new simulations, as I mentioned, but also at adding new or changing existing components in the model. But we also think, and that's why we basically developed it, it is especially helpful for developers that are not experts in all realms. So if you want to understand how your simulation works and you're a grad student and you haven't seen plenty of simulations yet, then this is something that you can easily judge your simulation by. It's like, oh yeah, CMIP-6, this is the bounds that CMIP-6 basically present. Am I in the bounds? Then I'm good. If I'm out of the bounds, I have to check, right? In a nutshell, but there's of course always the possibility to check because of something else. But this will give you a very clear indication if something is very off. It will not replace detailed evaluations, but it can be seen as an additional option to check the simulations while they're still running, for example. And then again, we submitted it to GMD. It's in revision right now. If you want to see the paper, you can scan the QR code or just look it up. ESMValTool itself is available in all different kinds of places. In decreasing complexity, as you can see, of course, everything is available on the GitHub repositories. It's fully open source. You can see every single line of code if you wanted to. So there's different GitHub repositories available. We have extensive documentation. It's on Read the Docs, and it basically tells you everything ESMValTool can do. It might be, some people tell us that it might be a little too extensive. Sometimes you don't find things, but it's indeed, everything is in that documentation. So everything you ever wanted to know about ESMValTool is in the documentation. It might be a little harder to find though. We have started implementing tutorials. So you can have them, you can see them on our tutorial website. It's something that we can that we use to teach, but it's also on how to getting started with ESMValTool, but it's also something that you could do on your own. It's fully self-explanatory. We are constantly trying to improve it with the feedback that we get to make it really fully self-explanatory. And it just, kind of like reduces the hurdle to get started with ESMValTool a little, and we hope that it will help to make sure people actually can use the tool for what it was invented. And then we have a website where we have all different kinds of information available and news and things. All right, and so this would be my last slide. We kind of already plan on all different kinds of things, of course. This is just a sub-selection of what we are thinking about for the future. We want to update the I/O functions beside the pre-processing functions to improve the memory-efficient data handling, which is getting more and more important with high-resolution data coming in and more simulations from different models, so that we can actually use everything and use ESMValTool to analyze multi-model, multi-ensemble means, and make sure that we can actually read everything without running into memory issues. We wanted to add more general purpose diagnostics, for example, Hofmüller plots for simplified simulation monitoring and evaluation. And we started adding basic model evaluation recipes. So we found that, especially if you want to look at very specific things, you're interested in clouds, then, kind of like you want to look at all different kinds of cloud-related diagnostics, very simple diagnostics, basically, is to see if your simulation is doing well in that specific area. And so we have started, those basic model evaluation recipes. We're looking at clouds or convection. This is what we are focusing on in our department. And but it will be helpful, of course, for everybody who would want to look into very specific parts of the Earth system. We have plans to add the chemical reanalysis data, not just CAMS, but probably more than that, because we are participating in ARIP, the reanalysis intercomparison project, to facilitate new diagnostics focused on atmospheric chemistry. And then we want to add more tutorial episodes for advanced users to make sure that, we don't lose people after we have given them a glimpse of what ESMValTool can do, and then there's a hurdle on how do you actually do this. So we try to make it easier for people to transition from understanding what ESMValTool can do for you and how the basics work to yes, I'm an active developer and I can actually contribute to this. That said, everybody is, of course, more than welcome to contribute in any way or form. There is a lot of things available on GitHub, discussions, issues and things. So don't be shy, just have a look. And if you have something to contribute, we are more than welcome to take it. That's it. Thanks.
Awesome. Thank you so much, Birgit. Do we have any questions? And thank you for sticking to time. Sorry. Yep.
Thanks so much for that. I just have a question whether this can actually be applied to different sets of observational data. I'm assuming it could, as long as they're gridded according to CMOR protocols?
Yeah.
Okay.
Yes. So it is possible to, what we have done, for example, in some diagnostics, is that we look at an observational mean to compare our simulations to. So that's a possibility. We have intercompared observations and reanalysis, as I had shown briefly. So that's, it is whatever is available in observation world we can use in combination with all different kinds of things, depending on what your idea is of what you wanted to do.
Thanks. As well as observational data, there's another sort of data, and that is the CMIP forcings, as in what is available at input for MIPS. So I was just wondering whether ESMValTool has been applied directly to that sort of data?
We have not, but it should be fine, is my thinking, as long as the data. So if you wanted to read the data and then intercompare it to something else, that should be doable. If you can, it's netcdf format, the input data should be in the right format, so it should be doable. So far, we have not had any application, I think, where we would want to look at that, like input from MIP data sets, but I think it should be doable, yeah.
Birgit, I was interested in thinking about high resolution. I guess you're using it for the icon model, so it's obviously usable for high resolution. But do you feel like ESMValTool will reach a limit where it's not really good for quick look things, or is it basically adaptable to anything?
Yeah, no, there is a limit. There is definitely a limit. I think the limit so far, besides the I/O, which is of course the obvious limitation, we are working on making that as lazy as possible so that it's memory efficient. That said, if we have too many simulations that we want to look at the same time, that might still be a problem, or it just needs a very, very long time. The other thing that I see the problem so far with the high-res simulations that we could look at is that we don't have the right diagnostics to do that. You don't want to, the high resolution, you don't want to just have an annual mean, global mean, because that doesn't really do it justice, right? You want to have like the very specific high resolution information to look at. And we don't have the, you can look at the global mean, but, we don't have the correct diagnostics yet to look to really do those simulations, the evaluation of those simulations justice, I think. I think that's for me, the biggest problem right now, after we have done most of the things we can do with the reading and the processing of the data to make sure that we actually can handle the big data.